Science exists as a way to provide answers to the pressing questions that we have about ourselves, the world around us, and even what lies beyond our own planet and solar system. Mysteries that have remained unsolved for decades can finally be put to rest with the development of better scientific technologies, and elements of ourselves and our world that we had no idea even existed can come to light thanks to the marvels of scientific research. Luckily, we live in a world where science has developed enough to finally answer age-old questions and discover these things that we did not even know in the first place. So today, here at Unexplained Mysteries, we will be diving into science discoveries and what they mean for our understanding of ourselves and the world around us. Release of Arctic methane could accelerate warming. The Arctic is recognized as the epicenter of the dispute over the vulnerability of frozen methane reserves in the ocean, which have now been dubbed the sleeping giants of the carbon cycle, and if discharges pass a tipping threshold, global warming might accelerate. The question of when, or even if, they will be released into the atmosphere has been a source of substantial uncertainty in climate computer models, as the Arctic temperature is presently increasing more than twice as fast as the worldwide average. Researchers are concerned that the discovery of high amounts of strong greenhouse gas down to a depth of 350 meters in the Laptev Sea in Russia may have extreme climatic effects. The Arctic slope deposits contain a significant number of frozen methane and other gases, which are referred to as hydrates. Over the course of 20 years, methane has an 80-fold greater warming effect than carbon dioxide. Arctic hydrate destabilization was originally recognized as one of the foremost catastrophic possibilities for anthropogenic climate change by the United States Geological Survey. The academic Keldysh 60-member team believes they are the first to determine that the release of methane is already underway throughout a large portion of the hillside 600 kilometers offshore. The emission of methane from Arctic permafrost regions' water and soils is known as Arctic methane release. Methane release is worsened by global warming, despite the fact that it is a long-term natural process. Because methane is a potent greenhouse gas, this has a detrimental impact. The Arctic is one of several natural sources of methane, a greenhouse gas. Meanwhile, a recent study showed that the release of methane from old carbon sources did not add much to the warming that happened in the last deglaciation, or the period after the last ice age. This occurred between 18,000 and 8,000 years ago, a time period that climate scientists are extensively studying because it is the last time global temperatures soared by 4 degrees centigrade, which is about what is anticipated for the planet by 2100. Many people believe that prehistoric methane emissions are not something to be concerned about in the 21st century, based on the findings of this study. This optimism, however, may well be mistaken. So what does this signify for climate change in the future? It means that, according to popular belief, carbon emissions from the warming Arctic may not be caused by the melting of long-frozen carbon capsules. Instead, the majority of emissions could be relatively new carbon created by freshly grown plants. This demonstrates that the age of the carbon emitted by the warming Arctic is less essential than the quantity and manner in which it is emitted. Over a 100-year period, methane is 34 times more potent as a greenhouse gas than carbon dioxide. Because young carbon will likely account for the majority of Arctic emissions this century, we may not even be alarmed by ancient permafrost contributing significantly to present global warming. However, carbon that was formerly in soil or plant matter will continue to leak into the atmosphere, making the Arctic a significant source of carbon emissions. This will become more common as the Arctic summer becomes longer due to rising temperatures. The new findings should prompt the international community to take aggressive action on climate change, limiting how many natural cycles in the Arctic can exacerbate the problem. Zombie greenhouse gases in the Arctic. Climate change is only increasing in speed, and part of that may be due to the fault of the Arctic Ocean. Did you know that each year, millions of tons of organic carbon and methane in the area thaw and ooze out to the surface? The carbon tied up in the organic matter and methane is found trapped in the subsea permafrost, which is also frozen sediment that became covered by seawater at the end of the Paleolithic Ice Age. Even though this zombie greenhouse gas could really impact the environment, it is hard to gather data on how fast the gases are leaking because the sediment is in such a remote and inaccessible area. However, two emerging theories have resulted. One of them, and arguably the scariest of the two, is that this greenhouse gas reservoir is a ticking time bomb that is bound to explode and suddenly spew into the atmosphere, which would trigger a climate disaster. The other tamer one is that instead of an explosion-like release, the gases will continue to ooze into our atmosphere as they have for centuries. Humans, however, have the capability to make the situation worse by speeding up the rate of release. At most, the acceleration would take place over several more centuries and not in the course of a few decades or years. Still, it is pretty frightening just to hear about how much zombie greenhouse gases are lurking beneath the surface. In attempting to capture a comprehensive picture of the ecosystem, they came to the startling conclusion that the permafrost holds about 60 billion tons of methane and 560 billion tons of organic carbon. On top of that, about 140 million tons of carbon dioxide and 5.3 million tons of methane escape from that permafrost into the atmosphere every year. In terms of comparison, that is almost equal to the carbon footprint of the entire country of Spain. From that data, experts arrived at the conclusion that over the next 300 years, the rate of greenhouse gas emissions from the subsea permafrost is only likely to substantially increase if carbon emissions from human activity continue to function as normal. Though more research is likely to change everything, there is no mystery about it that we as humans are linked to this permafrost below the cold Arctic Ocean. The part we play in it can impact the entire planet as we know it. The mystery of the green iceberg may soon be solved. With their blue and white colours, icebergs are a sight to behold. Because ice absorbs more red light than blue light, these colours make sense for glaciers. Researchers have proposed a new theory that could explain why some Antarctic icebergs are tinted emerald green rather than the usual blue, potentially resolving a decades-old scientific puzzle. Ice absorbs more red light than blue light, which is why it is blue. When floating in seawater, most icebergs are white or blue, but explorers and sailors have reported witnessing strange green icebergs near particular sections of Antarctica since the early 1900s. For years, scientists have been fascinated by the green icebergs, but now glaciologists say in a new study that iron oxides in rock dust from Antarctica's mainland are suspected of making certain icebergs green. Following the discovery of massive levels of iron in East Antarctica's Amery ice shelf by Australian researchers, they devised a novel theory. Iron is an important nutrient in phytoplankton, the microscopic plants that make up the foundation of the ocean's food chain. However, iron is in little supply in many parts of the ocean. If the new theory is genuine, it means that when green icebergs fall off, they transport valuable iron from Antarctica's landmass to the open sea, delivering this essential mineral to the creatures that maintain practically all marine life. It's like going to the post office and picking up a parcel, lead author Stephen Warren, a glaciologist and professor emeritus in the University of Washington's Department of Atmospheric Sciences, said the iceberg can send this iron out into the ocean far away, then melt and transfer it to phytoplankton that can use it as a nutrient. We used to think green icebergs were merely an unusual novelty, but now we believe they could be significant. To see if the theory holds up, the team planned to sample icebergs of various colours for their iron concentration. But what do you make of these curious discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thanks for watching, and don't forget to subscribe for more videos.